speakers. First, let's talk about IXP. Please welcome our international guest, Mr. Warren Finch from ISOC. Hello, Warren. Could you hear me? Hello, Warren. Could you hear me?
Yes, I can hear you. I just wasn't able to unmute myself before. Hello, everyone, and good afternoon. Is it okay if I share my screen for the presentation?
Yes, you can share.
Can you see my screen?
Yes, we can.
So I need to apologise up front. I'm actually at another conference today, and it's just coming to the end of the conference, so there might be some people walking by and some extra noise. So my name's Warren Finch. I work for the Internet Society, and I want to talk about the measuring the internet, in particular, whether the internet exchange points are able to assist in the role of measuring the internet. So when we look at measuring the internet, we want to look at things like questions and answer and validate our beliefs. So, for example, Miss Kine talked about the benefits of peering with the Internet Exchange Point, and she did some measurements of the latency and then was able to then demonstrate the benefit of that. The other reason you might need to measure is to set a baseline of what you know is normal traffic or what is normal, and then track changes over time. So you might do a measurement before you upgrade a router to make sure that the speed has been improved or the benefits that you have done for the upgrade is actually happening. So to demonstrate that value or justify the decision. A good example of measuring from an internet service provider's point of view is being able to see if you've got lots of congestion on a network, that might justify your decision to buy more bandwidth or to improve the hardware for the routing capability. And then I use that to identify opportunities for improvement or even just for knowledge. So, for example, you might be able to monitor your network and then figure out most of your customers are going to a particular website, so therefore you want to create some sort of relationship with that endpoint. And we'll talk about that. To help with this, the Internet Society created a platform back in 2020, and we call that the Pulse platform. And you can get access to it at the pulse.internetsociety.org. And what we're doing is that we get different data sources from various organizations, these open source data sets, and then we try and correlate and give information or extra information about that data. Or you can access that data in a raw format using our API. And the advantages of doing that is that we can start building out decisions. So, for example, looking at Myanmar, this is an example of the Sankey diagram, and we're looking at the top 1,000 websites that you will access as an end user going through your various internet service providers and where you are accessing those. So we can see at the top that you have local is the small blue bar. The green bar is you're accessing that information from a neighboring country or somewhere regional in Asia. And then if it's not regional, you're going external. So you're having to go somewhere like Europe or the United States. And so we can see that there is a lot of traffic because of the CDN capabilities of Cloudflare is going to that regional IXs or regional cache that is there. And so you can start looking at building up a decision to try and improve the end user experience by having a Cloudflare cache inside Myanmar, so at the MMIX. And that would mean that you would get better performance for the end user, and that blue bar hopefully would get bigger. And one of the goals of the Internet Society is to encourage lots of countries to create what's called a 50-50. This is a very similar diagram, just demonstrating over a different mechanism. So it's still measuring the same information, it's just displayed differently. So it's that local measurements over time. But we not only just do it for Myanmar, we do comparisons with other countries as well. And we can see there that everywhere that is blue is all your local content. That local content, we're trying to get it to get to the 50% mark. And that's that, I don't know if you can see it on your screen there. That's that middle line that we have down here. The orange line that you have. Oh, I'm not sure if I can mark that with a laser pointer, so you can see it around this point here. And we can see that a lot of countries have not reached that point. And ideally, if you get to that, it means that most of the top 1,000 websites are being served from your local cache or some local repo that is there. Doesn't mean you're not doing too bad with the internet. If it's green, it means that you're just having to go outside of your country. And that then means that you've got that transit cost, most likely. So when we're looking at measuring the internet, there are certain limitations to it. We sort of look at it from the point of view that we need to get access to open source data sets. We need to look at it from different vantage points. So what you see in your network may not necessarily be the same as what I see in my network. So therefore, we get different information. The quality of that, some organizations only keep the data sets for a certain amount of time, or they're not prioritizing the keeping of the measuring information. And so if the congestion happens to that particular network, they may not continue the capturing of the data. And so therefore, there's gaps in that. Consistency, again, is just looking at the quality of that data. And then the people that actually interpret the data sets have some biases. They're looking for particular information there. And so where IXPs come in is possibly they may be able to help with some of this. So for example, Ms. Kind showed you the data set of the traffic flows that were happening through the MMIX on I can't remember the length of time, but it was a way of looking at that measurement, how much maximum throughput per 24 hours, and we could then build up from that. And some internet exchange points actually do that because what they allow is a public looking glass that then allows other internet service providers or potential members to look up what sort of traffic is going through that IX, as well as who is available at that IX. And there's a famous quote from Lord Kelvin, which is an English mathematician from a couple of centuries ago. But basically, when we can measure what we're speaking about and express it in numbers, you know something about it. But when you cannot measure it, we cannot express it in numbers, and therefore you can't get a result. And so we need to think about, what do we want to measure? The internet measurements are going to be like health checkups. They help us understand where the traffic's going to and from. It helps identify where there's bottlenecks and how fast your internet experience is going to be. So a good example was that Ms. Kind showed the Akamai cache was being accessed via the international gateway rather than directly appearing with the IX. And so that causes some issues there. When we are thinking about our measurements, we think about it from an active measurement and a passive measurement. An active measurement is being able to send some sort of probe constantly to that target. And so that would be something like a ping, a trace route, and that can measure your performance, your latency, your jitter, your hops that you go through. Whereas your passive measurements are like your net flows, being able to observe the traffic without interfering with them. So you know from a DNS point of view that everyone's going to this particular website or they're using this particular tool. And so when we're looking at the types of network monitoring, we're going to look at mechanisms that are available to us. And each of those open source data sets that we've gotten access will use different parts of this. So not one type of monitoring will give us all the information that we would like to see. So we have things like real-time monitoring. So firewalls are a good example of this. They do real-time monitoring. Device and interface monitoring, so your net flows. Performance metrics. So you might be looking at, if you're monitoring your servers and your routers, you're looking at your CPU processing, your memory usage, your heat. If it's a server, the data, you might be looking at your disk size and how much free space you have. Based on those measurements, you will start looking at getting alerts. Or you can also send SM traps, so that way, SNMP traps, so that way you can get alerts and notifications. You can then use this information to then create visualization tools, similar to what I showed you at the start of this presentation, and the network mapping of what devices are on this network or how people are connecting together. And it then will help with other parts of your cybersecurity hygiene in regards to doing security monitoring or even remote monitoring and management. So based on some of the measurements, we can learn things about the latency, packet loss, which routing paths are your customers taking through your network. So when you try to get to a particular network, you might go a certain way. And then that certain way may give you congestion points. And you can make decisions about how to improve that. And so we can discover a lot about that. And there's a lot of research currently at the moment using large language models to help build a more detailed overview of how these packets and these measurement data sets are influencing our traffic. And then we need to make a decision about where do we measure. We can measure at the wide area network level. So we can use things like the RIPE Atlas. And these are a lot of, so the RIPE Atlas are servers or virtual machines that you can put into a data center that are readily accessible through RIPE's web dashboard or an API. And you can then create some measurements using trace routes or ping commands and get lots of information that way. Or you can get a simple, like a little Raspberry Pi, which is just a RIPE probe that you can put into a end user's network or into your network to be used for measurements. And it's a way of allowing any researchers or anyone that has an account with RIPE to be able to do measurements of some sort. And I find that's very useful to help demonstrate to networks that if they want to send traffic from this network to someone else's network, this is where the traffic tends to go through. From an enterprise point of view, we'd be looking at the local area network, and you've got different devices on your network that you could use to do measurements and gather data from. You've got your router or your gateway, you've got your Wi-Fi access points, you've got your end devices, whether that's a gaming device, a printer, a laptop, a phone. They can all have some sort of measurements on there. At the network level, we might want to start looking at the control plane, getting information from that. And that's where we have the route views, and that is more looking at the router's view of the networks and the internet in general. You've got Packet Clearinghouse, and you've got Looking Glasses and RIS from RIPE NCC. So there's lots of opportunities out there where you can get some open source data and start playing with that. From peering and interconnection, internet exchange points play a critical role, an important role for this, and it helps to improve the internet performance and resilience. And that's why we think at the Internet Society that measurements from the IXPs point of view will help identify these new peering opportunities and where they could be. And so the problem that we have, though, is that there's going to be some data gaps. Not every IX does measurements, or not every IX publishes their measurements for anyone to interpret. So that is an issue there. So we're hoping to encourage more and more internet exchange points to have some sort of public looking glass, as well as some sort of data set that can be centralized, and then we can start using those to make decisions with. And that helps to make better decisions. So from the opportunities point of view, we can get a better understanding of the internet topology if we have more and more information and more data sets that we can use. Based on that, we can hopefully improve performance for the end users, and we can get insights about where would be the best place to peer or do interconnections based on your net flows of your own network. There was a research done in South America where they were able to basically get your configs or your net flows, interpret those net flows, and then tell you about this IX is best suited to you because most of your traffic goes to this customer profile, and this is where you can make the best peering decisions for that. The disadvantage, though, is that tooling is only as good as the data sets and the knowledge that it has of where all the connections are. Some coverage gaps exist, so therefore there are some assumptions made, and it may not be the correct decision. It's like putting together a puzzle with certain pieces missing. So that's a bit of an issue. So what I'd like you to do is to think about these questions. So from the perspective of an IX, what can the IX offer us that we don't already have? So if you think about your own research that you do in using internet measurements or any sort of network measurement tools, what do you have that you're not getting at, or what is something that you would like that you don't have? What can the IXs offer from this? Why can't the IXs offer this information as well? So a lot of internet exchange points already provide the public data. Some of the IXs don't, and they have challenges to do this. And why are there those challenges? What would an IXP measurement system look like if we were to build one from the ground up or from scratch? What do you need? What data do we want to collect? And how would that data contribute to the measurement overall? So if you're interested in this, please feel free to send me an email or reach out to me if this is of interest. We've got lots of peering research fellows that have just started this year, and they're looking for projects. And so this is something that we could do. Before I finish, I would like to talk about the Internet Societies. We have infrastructure, technical communities, and community leads network supported. So since 2020, we've supported 64 new or existing IXPs with grants totaling over 1.5 million US dollars. We also support the ISOC chapters and network operators group, and we give funding to them. So we've supported at least 44 different groups and given over $200,000 through grants. And we've got more grants that have opened this month. They close early next month for IX development. And we also have early career and mid-career fellowships that help sponsor people to go to conferences around the region to improve your training. We also offer training courses that are free, similar to other organisations like ICANN, ITU, and APNIC Academy. Our focus is more on the fundamentals and advocacy and Internet Exchange Point. So feel free to have a look at the Internet Society's website to look at that. And this is a breakdown of our catalogue. So we've got technical skills, we've got online safety skills, we've got advocacy skills and knowledge exchange for businesses. So feel free to have a look at those. So thank you for your time. And if you want to find out more about Pulse, take a screenshot of this. So thank you.
Thank you so much, Mr. Warren Finch, for that global perspective on IXPs. Please excuse me if I mispronounce your name when I'm calling you.
No, you got it right. It's okay. But
thank you. Now,
are there any questions?
any questions? No, mister.
Okay, so thank you. I will stop my share and hand it back to you.
Okay, now we have a fun quiz session for your topic. Quiz session, please.